So today we're going to be talking about parent functions. It's 1.6. You'll have an assignment for it on WebAssign. I kept the assignment fairly short. The objectives for this assignment are to be able to identify and graph linear and squaring functions. So ultimately, the idea of these is to be able to look at a graph and kind of know what the parent function is. Is it a square function? Is it a cube function? Is it a square root function? Is it an absolute value? Is it a step function? Is it piecewise? And you should be able to recognize this just from looking at the graph of the function without having to do too much work. So that's the whole idea of this. There are a lot of slides in this. I'm going to go through them relatively quickly. There's only a couple I will do sample problems for because I know it's something you've never seen before. Beyond that, your assignment is fairly small because it's really just an understanding of whether or not you know how to do this. And most of them will be related to greatest integer functions and piecewise functions because that might be something that's new to you. Oops, I didn't want to move the whole slide. Just want to move this up. So first we're going to talk about linear and squaring functions. These you guys have worked with extensively, right? They're XY functions for a linear function without any powers, right? It's Y equals X, right? And squaring functions would be Y equals X squared. And so our parent functions of these, one of the goals of this text is to enable you to recognize basic shapes of the graphs. The graph of a linear function is literally a line, right? You guys know how to do it. It's the Y equals mx plus b. You've got a slope. It's a line, right? Y-intercept is your b. You guys have seen it over and over and over again. You've seen it in Algebra 1. You've seen it in geometry. You saw it in Algebra 2. We've done it again here in pre-calculus. You know it's important because we've done it over and over and over again. So when you see this in the form of a graph, you would have, let's see if I can get this thing to write. Oh, my tablet's turned off. That's why it wasn't working. So if I want to graph something like this, it would look like, here's my, oh, this is terrible. We don't need it perfect, right? We would have a dot on here, right? A point at, say, whatever B is, would be our intercept. And then whatever our A is our slope. It's our rise over run. And it would just graph as a straight line through that point, right? All linear functions are just the graph of a line. The graph of a linear function has the following characteristics. The domain of the function is the set of all real numbers. That means our x can be anything we want it to be, from negative infinity all the way to positive infinity. When m is not equal to 0, so when the slope is not equal to 0, the range of the function is the set of all real numbers as well. Talking about a line, right? Which means if you look at this graph I made, it can go up forever and it can go down forever, right? Linear function, that means that we can have any value of x, so our domain is all real numbers, and we can have any value for y, right? This goes on forever, this goes on forever, so we can have any value of y as well. So our range and our domain are all real numbers. The graph has an x-intercept at the slope, right? Anytime we set y equal to 0, whatever our x's become when y equals 0 is our x-intercepts. right? And our y-intercept is always the b in y equals mx plus b. Do you need to know all this? Not necessarily. This is just saying that your graph increases when you have a positive slope. It decreases when you have a negative slope. And it's constant when your slope is 0, right? Which makes sense. It just means you have a vertical line between whatever your x is. This is all stuff you've seen before. It's just in weird language. This I wanted to focus on right here because you are going to have some problems like this in your homework. It's going to ask you to write a linear function, which you know how to do. It wants you to put this in y equals mx plus b form, right? I'm going to make this pen smaller so that we can see this. And you're going to wonder, well, what is my x and what is my y? Well, here you are you're shown your x and your y, because what we're inputting right here is our x value. So we're going to have a point at an x value of 1, and what it equals is our y value. So our y value is 3. So we have 1 point at 1, 3. We have another point at 4, 0. Those are our 2 points for us to get to y equals mx plus b. Then you just have to go through the steps, right? Now, they're showing you the first part. They're saying, well, first thing you have to do when you have 2 points is find the slope. And to do that, we're going to do our y1, y2 minus y1, right? So we're going to make this x1, y1. And we're going to make this x2, y2. It's arbitrary, right? I'm using the same points that they have. And I'm just going to go ahead and find my slope. You guys know how to do this. We're going to go 0 minus 3 over 4 minus 1. And we're going to get a slope of negative 3/3, which is just negative 1. So we know what our slope of this line is, and we know what 2 points on the line are, right? So all we have to do now is plug those into the point slope form. And if you remember, it's listed right here, but I will rewrite it. It is y minus y1 equals m times x minus x1. And we know what m is. We just found it, right? It's negative 1. And we know what y1 is, right? Let me put in the minus here. We can use either of these 2 points, right? But we already have one that's slated as 1 and as x1, y1. So I'm just going to plug those in where I see them, right? So I am going to go, my y1 is 3. So I have y minus y1, y minus 3. My x1 is 0. So, oh, sorry, my x1 is 1. I was looking at the other point. Let me erase that. And then I can just go ahead and solve. And when I solve for y, I get that y equals mx plus b that I'm looking for, or that f of x equals mx plus b. So I would have y minus 3 equals, and I'm going to distribute, negative x, distribute, becomes plus 1. I'm going to add 3. I'm going to add 3. And I get y equals negative x plus 4. So that's my mx plus b. My slope is negative 1. My y-intercept is 4. When I want to put it in function notation, if it specifically asks for that, all I have to do is change my y to f of x, right? So I would have f of x equals negative x plus 4. So the only thing that's different that you haven't done is to understand that, where'd that go? Is that these make your points, right? This is your x input, and what you get out is your y. So if you're given points in this notation, right, f of 1, it's saying when x is 1, what is y, right? So in this case, when x is 1, y is 3. In this case, when x is 4, y is 0. So that's how you're going to solve those. You will have some of those in your homework, and I just wanted to make sure that you knew how to do them. You guys know how to graph a line, so I'm not going to go into that. But, you've got your 4 make sure, y-intercept, and then you can set your other point, right? It's your slope is negative, so you could go down 1, plus 1, down 1, plus 1, down 1, plus 1 forever and ever. Or you can go up 1, negative 1, up 1, negative 1 forever. When you have f of x equals c, remember that f of x is just y, right? So that's like saying y equals c. So wherever c is here, you're going to have a straight line. So if I had y equals 3, that would graph as a straight line through 3. That's all that means. F of x is y. C is just some number, right? We don't know what the number is. If the number was 3, it would be at 3. But your parent function is y equals c, and we just have some random number that's going to be c to show you how the parent function of that is. We already do that. This is just the graph, right? And it's showing you that the domain and range is the set of all real numbers, in that I can choose any x to fit in here, and there will be a y that fits it. And because the set of x is all real numbers, and we've got our y going infinitely in both directions, the set of y, or f of x, would also be all real numbers, which means your domain is the set of all real numbers, and your range is the set of all real numbers. When we're talking about the graph of a squaring function, it just means anything that says raised to the second power. These are less complicated than they think. We create all this language that makes them hard, but really the graph of a square function is just f of x equals x squared, or y equals x squared. Now, again, the domain of this, our possible x values, can be anything. We can choose anything we want for x. But the range, when you think about it in a positive, if you have a positive x, it's going to be all non-negative real numbers, right? The function's even. This x is positive, which means that when we square it, it's going to be positive. And so it's never going to get below 0. When you see this graph, sorry, this is an ugly graph, but it doesn't need to be pretty, right? When you see this, it's going to graph like the U, right? In both directions, the parent function, right? It's going to go like this. We're never going to have a y value below 0 when we graph that in a proper squared function. Oh, look, here, they went and showed us one. The graph is decreasing on the interval negative infinity to 0. It just means from here to here, it's going down. It's increasing on the interval 0 to infinity. That means from here to here, it's going up. That's all that means. It's symmetrical with respect to the y-axis. That means everything that's happening on this side is happening opposite on that side. If we folded it in half on that y-axis, all the points on each side would line up. That's what it means to be symmetric with respect to the y-axis. And it has a relative minimum at 0, 0. It just means it has this point. Its minimum value, its vertex, is at 0, 0 when it comes to the parent function. Anytime we have a parabola that's off of there, it means there's some kind of a transformation happening on it. Whether it's raised up or down or left or right, it's because of a transformation that's happening on it, which we're not talking about until the next ed puzzle. So you don't need to worry about that. What we're just looking at is what does a square function looks like. It is a parabola with a vertex at 0, 0. Cubic, square root, and reciprocal functions. These you just need to be able to look at them and understand what they are in terms of the parent functions. I took out any real questions that deal with this in the homework. You can look at in terms of with cubics, you've got the square roots, and the domains are all real numbers, and the range is all real numbers, and where it graphs. But what I just want you to do is be able to look, for the most part, at these and understand how they graph and what their graphs look like. So this would be the graph of a cube function, right? A cube function has this deal, right? It goes through 0, 0, and it kind of curves up on the positive x side, and it curves down on the negative x side, right? If this was a negative function, that would rotate, right? It would curve up from here and go down like that. But that would also be a transformation. Our parent function, though, looks just like this. So if you see something of this shape, no matter where it is on the graph, you know you're dealing with something cubed, which is the whole purpose of understanding parent functions. And like I said, I'm not giving you a bunch of sample problems on these because you're not going to have problems to do. The whole idea is for you to be able to look at one of these graphs and understand it. And I did post that form for you guys in PowerSchool. The graph of a square root function has the following characteristics. The domain of the function is the set of all non-negative real numbers. It starts at 0 and goes up. We don't have negative x values in the parent function. The range, also the set of all non-negative real numbers. It only goes up. It stays in that first quadrant. So this is a square root function. Notice that it starts here and gets bigger, right? Think about what a square root is. If I have the square root of 4, I'm getting a positive outcome. I can't have a negative square root of 4 or a square root of negative 4 because that would make the number imaginary, right? Nothing times itself equals negative 4. So look at the shape of your graph. That's all you're really concerned with right here. So that when it moves, you can kind of identify it. You can identify the shape even if it starts at 3, right? Even if it started at 3 and made that shape, you'd understand that it's a square root function. It's following that pattern. I'm not going to use a lot of this. This is a fractional function. We call it a reciprocal function. Think about the reciprocal because one is up, one is down, right? It's their opposite of each other. You're going to get double graphs because what happens if I go to negative x? I get this same thing, but in the negative. If I'm putting in negative x values, we're never going to get 0. Why are we never going to get 0? Because we aren't allowed to divide by 0, and we're talking about a fraction. We're talking about a variable in the denominator, and that denominator can never be 0. So you notice it splits off there. It's 2 pieces, right? We can never have a 0 for an x. So we're having, if I put in 2 here, I've got 1/2. If I put in 3, I've got 1/3. If I get smaller than 1, I'm going to start going up, but I'm never going to reach this line, and I'm never going to reach this line, right? And that's going to happen when I do the negatives on the other side, the same thing, right? If I have -1 or -1/2, it's just going to keep getting smaller here, and here it's just going to keep getting closer and closer to that x-axis. It's never going to cross it. I feel like I'm going fast, but I'm really tired already of talking. But this is the main reason I wanted to do a video for this, is because you guys haven't seen a lot of step and piecewise functions. Functions whose graphs resemble sets of stair steps are known as step functions. The one you're going to be dealing with today, and the most famous step function, is the greatest integer function. And it's denoted by, see those two little liney brackets? And it's defined as f of x equals the greatest integer less than or equal to x. What does that mean? Some values of the greatest integer function are as follows. Now, what it's saying is the greatest integer less than or equal to 1, -1, right? So the less than or equal to -1 would be -1. The greatest integer, remember, integers are whole numbers, less than or equal to 1/2, -1/2, I apologize, would also be -1. So whatever you're getting, it has to be the whole number that's just less than it, right? So if I had, I can never make these stepwise functions. Say I had, I think it's like a bracket with a line. -2/3, right? The greatest integer of that would also be -1, because it's the one closest to it. If I had the greatest integer function of 4.2, it has to be the integer closest to it on the left less than side. So it would be 4. If I had the greatest integer of 4/3, right? That's just a little bit over 1, right? It's like 1 1/3. So the greatest integer less than it would be 1. I hope that makes some sense to you. As far as how to deal with greatest integer, here we've got greatest integer less than 1/10. Well, what's the first thing less than 1/10? It's not going to be 1, right? Because 1 is bigger than it, so it's going to be 0. The greatest integer less than or equal to 1/5 is going to be 1. It's not like rounding up. You're always going to round down to the lesser integer. 1.9, we're really close to 2, but it's still going to be 1. And the graph, you can see, has this characteristic, right? Anything between 0 and 1, you're going to graph the whole thing. You're going to have an open dot at 1, because once it hits 1, it becomes 1 all the way up till it gets to 2, which 2 would be 2, and then it would start at 2 and then go all the way to 3. All right, so anything between those numbers is going to go to whatever's less than it. The domain of the function is still all real numbers, right? There are no real numbers. We can't make x. We just know that their y is going to be whatever the less integer is. The range is all set of integer, the set of all integers, right? We're not going to have any fractional solutions in the y, because everything has to be a whole number. It's going to the lesser integer, right? Notice there's nothing in between these on the up and down. We can have any x value, but we can't have just any y value. When evaluating a step function. So it says evaluate the function when x equals -1. What does that mean? It means what is f of -1 when we're talking about step functions. And it just means that here where we would have x, we're going to put in -1. And so -1, well, they're saying -1 plus 1. So let me make sure I have that plus 1 there, right? So we're going to look at what is the value of -1, the step value of -1 plus 1. Well, we know that this is right. This is just -1. So it's like saying -1 plus 1, which equals 0. What if I said, what is the value of -3.5, right? For that same, right? The value of x step plus 1, right? What we're going to do is we're going to go, okay, well, in this case, that -3.5 becomes -4 because it is the first whole integer, right, that's less than it. And then we would go -4 plus 1, which equals -3. So that's how I want you to look at this. Review this. I hope you took some notes. They already did this one up here, which is another one. I'm not going to show you another one on that. Verify your answers by examining. This is just the graph of it, but you can see it, right? It's still following that same step function graph. And all your, excuse me, all your homework problems are going to do is tell you to pick which graph it is, right? So if it's x plus 1, it's following the same thing. Here we've got parent functions. I'm not going to go over this with you because you guys can see it. I actually posted it in your PowerSchool. It's just what are your basic functions, a constant function, an identity function, absolute value, square root. You have all of these in PowerSchool on a form that I gave you. Quadratic or square function, cubic function, reciprocal is fractions, greatest integer is steps. The one thing I want to show you that I'm not seeing on here is a piecewise function. And I know I kept one in, but I want to show you one, and then I'll end this video so that we can all get out of here. Say I have g of x. That's just what we're calling the function. And it's x plus 6 when x is greater than or equal to -4. And it is x minus 4 when x is greater than -4. All that means is when we go to graph this, ooh, that's an ugly graph. I'm going to redo that. Almost done, I promise. So say I have this graph. Let me get rid of the ruler there. When I go to graph this, it's saying that when x is less than -4, so let's call this -4, we are going to use x plus 6. So at -4, our y would be -4 plus 6, which is 2. So at -4, I'm going to have a point here at y equals 2, right? It's equal to, so it's solid. Let's look at what's less than that. Let's look at -6 plus 6 equals 0, right? We're going to have another point here at 0, and it's just going to follow that pattern. It's going to graph down that way, right? Following that same process. At x is greater than -4, so at anything greater than -4, we're going to use the other equation. So at x minus 4, so at -4 minus 4, I'm going to have 0. So here at -4, I'm going to start another point at 0. It's open. It's not actually equaling that, right? But at, say, what if I make my x 0? That would be 0 minus 4, and that would give me -4 as a solution. So here at -4, I'm going to have another dot, and this one's going to be graphing in this direction. I know you have one that looks like that. I know this video ran long, but we didn't do a lot of math in it. Pay attention mostly to the step and piecewise functions, because that's what's new to you. This should get you through your Delta math on parent functions. I tried to keep it relatively simple, but remember, the idea is mostly just being able to identify what kind of graph it is. Use the sheet that I printed out, that I posted on PowerSchool for you. If you have any questions, you know how to reach me. Please don't hesitate, and I will talk to you all soon. So thanks, guys.